For problem 9, it tells us that x1, x2 to xi is a sequence of independent random variables where y, and we are given that yn is equals to the sum of xi, I is from 1 to n, and they tell us to prove or disprove that yn is a Markov chain. So if yn is a Markov chain, we need to prove that the probability of n minus of y n n plus 1 is equals to 1 yn plus this one yn plus 1, given that yn equals to yn minus 1 equals to yn minus 1, and all the way to y1 equals to y1. And if yn is a Markov chain, we need to prove that this probability is equals to this one. This is the probability of yn plus 1 equals to yn plus 1, given yn equals to yn. So first we notice that it gives us this equation. Yn is equals to the sum of xi, I is from 1 to n, and we can substitute this yn this yn minus 1 here. So yn minus 1 can be converted to xn plus 1 plus yn, and we can continue transfer this equation. We can convert this capital Y to the lowercase y, and we can move this lowercase this yn to the right of the equation, and also we can see that move to the right of the equation where yn is equals to yn minus 1 equals to y minus 1, all the way to y1 equals to y1, and we can see that the probability is only matters the yn equals to yn, and the other items are useless, so we don't want them. And after we doing this, we can move the yn to the right part of the equation and convert it to the capital Y, and so it is the probability of xn plus 1 plus yn equals to lowercase yn plus 1, given that yn is equals to the lowercase yn, and we recover the left part of this equation, and which is the probability of yn minus plus 1 equals to yn plus 1, given that yn is equals to yn. So we prove that these two probabilities are the same, and it can be proved that it is a Markov chain.